Right, so this is section 11E2. So before, what we did is figure out how to calculate chi-squared. So we got some sort of a value. In this case, our value was 0.2170. But what do you do with that? Because remember, the whole point of chi-squared is you're just trying to see, are these variables independent? So that's what brings us to this one. This is the formal test for independence. And before we get into that test, I do have to talk about a few things first. So first of all, for a contingency table. For a contingency table which has R rows and C columns, we have to find something called degrees of freedom. All right, this is called degrees of freedom. I didn't actually write it down, but this is degrees of freedom. All right, so the degrees of freedom, so it's just R minus 1 times C minus 1. That's all it is. And I also said here, don't include the sum of the row or column, the sum row or the sum column, like that column at the very bottom or the column or the row at the very bottom and the column that comes at the very end. Don't include those. You're just including the cells that have your original data. That's all you're including. And then also the significance level. This is something that will be given to you. They will say test with a significance level of, let's say, 5%. All right, so this part is given to you. You don't calculate this. This is given. And that's the minimum acceptable probability that the variables are independent. Move that over just a little. So that is your significance level. Now, given the significance level and the degrees of freedom, you can find the critical value of chi-squared from the table on page 338. And let me show you right quick here. Let's see. This is on page 338. So this is what I'm talking about right here. These are the critical values. So based on the significance level and the degree of freedom, you can figure out what what the critical value has to be. All right, so that's how you find the critical values. Again, you have to find degrees of freedom first, and then look at the significance level that they give you. And once you have those two things, you can look it up in the table as to what the critical value is. All right, so with that out of the way, now we can get into the formal test for independence. So there's different steps here. Just kind of follow the steps. Your very first step, state if H null, and this is called the null hypothesis. This isn't H0 or H sub 0. This is called H null. This is called the null hypothesis. And this is where we say that the two variables are independent. If I say they are independent, that is called the null hypothesis. Now, H1, this is called the alternative hypothesis. This is that the two variables are not independent. So the alternative hypothesis is that the variables are not independent. Step 2, state the rejection inequality. So this is right here is the rejection inequality. Your chi-square value greater than k. That's the rejection inequality. Where k is the critical value from that table on page 338. Now, for some of these problems, they will give you the critical value. You won't even need to look at the table. And I will also say this, like on the IB exam, like the big exam you take next year, if you have a problem like this, they will give you the critical value. You will not have to look it up from a table. Step 3, move this up just a bit. Maybe I can move this down even better. A little bit better. Step 3, construct the expected frequency table to calculate chi-squared. Okay, so once you have the expected frequency table, then you can calculate chi-squared. Or you can use a calculator. And I will show you at the end of the video how to use the online calculator. There's an online calculator that you can use, so you don't have to do this by hand every time. All right, once I have this chi-squared value, once I calculate that, I reject H null if chi-squared is greater than k, whatever that critical value was. If it's greater than that, then I reject H null. I do not reject H null if chi-squared is less than. All right? So if it's less than, I do not reject it. We do not say we accept anything. You either reject it or you don't reject it. Okay? You never say I accept H null. Do not say that, because you could be missing some data. Or more to the point, I mean, there's that certain chance that even though it's within a certain parameter, it may not be totally accurate. So you never say except H null. You just simply say you do not reject H null, because later on you might end up rejecting it. Step 5. Now, P, this is your P value, and I'm going to tell you what P is here in a second. But the P value, if it's less than significance level, then we reject H null. If the P value is greater than the significance level, we do not reject H null. So, speaking of P value, what is the P value? This is the p-value. So a p-value is the probability of obtaining values as far or further from the expected values, assuming variables are independent. So assuming they are independent, that's the probability of obtaining those observed values. They're either as far or further than the expected values. And as you can tell, if you have a larger p-value, that probably gives you a greater chance. In fact, it says it right here. P is greater than the significance level, we do not reject H null. H null, remember, is the null hypothesis that the two variables are independent. Okay, and last but not least, take a minute, copy example 7 on page 340. I don't really have to add anything extra to it. I'm going to walk you through it, but I don't really have to add anything to it. So go ahead and copy that example. Once you have that copied, I will kind of go over it with you very quickly just to make sure everybody's good on it. So a survey is given to randomly chosen high school students from years 9 to 12 on possible changes to the school's canteen. So in other words, a cafeteria. The contingency table shows the results at a 5% significance level. Test whether the student's canteen preference depends on the year group. Okay, so we're trying to see if these are independent or dependent. So this many wants to change, this many does not want to change, and these are all ninth graders. Okay, and we're trying to see is it independent or dependent. So let's see here. Let's follow the steps. First of all, again, step 1, state H null and H1. So your null hypothesis and your alternative hypothesis. So the null hypothesis is that year group and canteen preference are independent. That's the null. And then your alternative is that they are not independent. After you do that, we have to find degrees of freedom, and we need to know the significance level if we are going to find the critical value. Degrees of freedom. So I said it's R minus 1 times C minus 1. So number of rows minus 1. I've got 2 rows, so that'd be 2 minus 1, times, well, 4 columns, so that'd be 4 minus 1. And so 2 minus 1 times 4 minus 1 will get you 3. And the significance level, they gave it to you. Like I said, significance, they will give that to you. So 5%. Now we can look at the table, and when you look it up, it's going to be 7.81, and you can verify that. See, our degrees of freedom was 3. Where is it? Yeah, right there. Okay, so degrees of freedom was 3, and our significance level was 5%. That means my critical value is 7.81. So I found that, and I write out the inequality. So we reject H null, the null hypothesis, if my chi-squared that I calculated is greater than 7.8. So next step is to calculate the chi-squared value. So you calculate the chi-squared value. You can calculate it by hand, or you can use the calculator. And I'll show you the calculator after I finish this example. For sake of brevity, let's suppose we use the calculator. All right, I use the calculator, and it gives me this right here. So about 5.81. Now that is less than my critical value of 7.81. So what does that mean? Well, let's see. I have to reject it if chi-squared is greater than, but it's not. It's less than. So I do not reject H null. Again, you do not say except H null. You simply say I do not reject H null. Let's see. Or you say, wait, do not reject H null. Yeah. So you don't say accept H null. Just trying to get that straight in my head. Let's see. It also gives you the p-value. So when you do the calculator, it will give you a p-value. And notice your p-value here is greater than 0.05. So that provides further evidence to not reject H null. Ideally, you should not have an inconsistency here. So if this tells you not to reject H null, this should also tell you not to reject H null. Ideally, now you may run into a situation where it doesn't work out that way. And in that case, then it's kind of indeterminate as to whether they really are independent or dependent. But based on this, I can conclude at a 5% level of significance, the variables, year group, and canteen preference, they are independent. And finally, the calculator. So let me show you the calculator because you probably don't want to spend a whole lot of time. This is the calculator. It goes chi-squared, and let me hit start again. Okay, so this is where you enter in the data that they give you. So essentially what you're making is the contingency table. I'm just going to kind of leave it like this. All right, suppose we have a 2 by 2. And we'll just hit next. So once you put the name of your categories in, then you put the data. So I'm just going to make up some numbers. And see, I want them to be greater than 5. We'll talk about that in the next part. We'll talk about why they need to be greater than 5. All right, hit next, and then we're done. Well, I'm sorry, we have to say the significance level. So make sure you choose the right one. So this is 1%, this is 5%, this is 10%. So let's just go with 5%, so 0.05. And now, okay, I can say that I'm done. Calculate chi-square. It will give you the chi-square value, and it will also give you the p-value. So it gives you both. So it gives you chi-squared and the p-value, right? So that's how you use the calculator. And with that, you should be okay.